If you have always been fascinated by the greatest unsolved mysteries on Earth, and you enjoy discovering stories that most people have never heard before, please take just a moment to like this video and subscribe to the channel, because your support allows us to continue uncovering hidden secrets from history that refuse to stay buried. High above one of the driest deserts on Earth lies a mystery that has challenged archaeologists, scientists, explorers, and historians for generations. The Nazca lines have remained almost unchanged for centuries, stretching across the Peruvian desert in the form of enormous animals, geometric figures, and perfectly straight lines that can only truly be appreciated from the sky. For decades, experts believed they understood the basic nature of these incredible geoglyphs. Some argued they were ceremonial pathways. Others believed they represented astronomical calendars, while another group suggested they were connected to water rituals, agriculture, or religious traditions. Every generation produced a new explanation, and every explanation seemed convincing for a time. Yet none of them answered every question. There was always something that refused to fit the accepted theory. Then, something changed. Not because archaeologists suddenly discovered a hidden temple beneath the sand, and not because explorers uncovered an ancient manuscript describing their purpose. The breakthrough came from something completely unexpected: artificial intelligence. A technology designed to recognize relationships that humans often fail to notice was asked to examine one of history's greatest archaeological puzzles from an entirely different perspective. Instead of looking at individual drawings one by one, researchers allowed advanced machine learning systems to process decades of satellite imagery, aerial photography, drone surveys, elevation maps, historical records, and modern high-resolution scans all at once. Within hours, the software had analyzed more visual information than a human expert could realistically study during an entire career. At first, researchers expected the program to simply organize existing knowledge more efficiently. Instead, the system began highlighting unusual relationships between figures separated by enormous distances. Certain animals appeared repeatedly aligned with specific geometric shapes. Several straight lines pointed toward locations that had never attracted serious archaeological attention before. Even more surprising, many recently discovered geoglyphs appeared to complete patterns that nobody had previously realized even existed. The software was not programmed to search for mysterious messages or hidden civilizations. It simply searched for mathematical consistency, repeating orientations, spacing, symmetry, and structural relationships. Yet the more information it processed, the stronger one conclusion appeared to become. The Nazca lines might never have been intended as separate drawings at all. They could represent individual pieces of a much larger design, spread across the desert on a scale so enormous that no ancient observer standing on the ground could ever fully appreciate it. That possibility immediately captured worldwide attention because it challenged more than a century of traditional thinking. If the figures were intentionally connected, then generations of researchers may have been asking the wrong questions from the very beginning. Instead of wondering why somebody created a giant hummingbird, a spider, or a monkey, perhaps the real mystery was why they were positioned exactly where they were. Why did certain lines continue for remarkable distances with extraordinary precision while others suddenly stopped? Why did several figures appear to face identical directions despite being separated by many kilometers? Could these choices have been deliberate rather than accidental? These questions were not entirely new, but artificial intelligence gave researchers something they had never possessed before: the ability to compare every visible feature simultaneously without becoming overwhelmed by the sheer scale of the landscape. Human observers naturally focus on individual objects, Computers excel at recognizing relationships across massive collections of data. That difference proved incredibly valuable. As more imagery entered the system, subtle clusters began emerging. Several groups of geoglyphs shared similar orientations. Others appeared connected through invisible geometric relationships that only became obvious when viewed together from extreme altitude. Some straight lines intersected at locations where no visible figure existed, almost as though something important had once stood there, or perhaps never required a visible marker at all. Archaeologists immediately approached these results with caution. Artificial intelligence can identify patterns even where none truly exist, and history has shown countless examples of researchers seeing meaningful designs inside random information. Every apparent discovery required careful verification using traditional archaeological methods. Teams returned to the desert carrying sophisticated mapping equipment, comparing computer predictions against real terrain measurements. Surprisingly, many of the predicted relationships proved accurate. This did not automatically reveal the purpose of the Nazca lines, but it demonstrated that the computer had identified genuine structural consistencies hidden inside one of the world's largest archaeological landscapes. As word spread throughout the scientific community, interest grew rapidly. Experts specializing in geography, engineering, mathematics, anthropology, and remote sensing began collaborating in ways rarely seen before. Every discipline brought a different perspective. Engineers studied construction techniques. Geologists examined the surrounding terrain. Anthropologists explored cultural significance. Mathematicians searched for repeating proportions hidden beneath the immense network of lines. Each new investigation seemed to raise even more fascinating questions, rather than providing simple answers. The desert itself added another layer of mystery. Unlike many ancient monuments that gradually disappear beneath vegetation or heavy rainfall, the Nazca Desert preserves surface markings with remarkable stability. The combination of dry climate, minimal wind, and unique soil conditions allowed drawings created many centuries ago to survive almost untouched. Every generation inherited the same enormous puzzle, but each possessed different tools for studying it. Early explorers relied on ground observations. Later researchers used aircraft. Modern scientists introduced satellites, drones, laser scanning, and now artificial intelligence capable of processing unimaginable amounts of information within minutes. With every technological leap, the mystery seemed to grow rather than shrink. Some of the newest geoglyphs identified during recent surveys were so faint that they remained invisible to the naked eye under ordinary conditions. Only specialized image enhancement techniques revealed their outlines. Artificial intelligence successfully distinguished these subtle traces from natural erosion, helping researchers identify figures that had escaped detection for decades. Some depicted animals, others appeared purely geometric. A few resisted classification altogether, refusing to resemble anything familiar. Even more intriguing was the observation that these newly discovered figures frequently occupied positions predicted by computer-generated spatial models before archaeologists physically confirmed their existence. That remarkable coincidence encouraged researchers to expand their analysis even further. Instead of viewing the Nazca Plateau as a collection of isolated artworks, they began considering whether the entire landscape functioned as a carefully organized system. Such an idea remains controversial because extraordinary interpretations require extraordinary evidence. No responsible archaeologist claims that artificial intelligence has solved the mystery. The software cannot explain ancient beliefs, intentions, or cultural traditions. It cannot read lost languages or reveal forgotten ceremonies. What it can do is identify relationships hidden inside overwhelming amounts of information, allowing human researchers to investigate possibilities they might never have considered otherwise. That alone represents a profound shift in archaeological research. Technology is no longer simply documenting ancient sites. It is actively helping experts ask better questions. And sometimes asking the right question becomes more important than finding an immediate answer. As researchers continued refining their models, one observation repeatedly appeared impossible to ignore. Several of the strongest geometric relationships seemed concentrated within specific regions rather than distributed randomly across the desert. These clusters hinted at deliberate organization. But if that was true, who designed such an enormous system? How did they maintain such astonishing precision without modern technology? And what exactly were they trying to show to anyone capable of seeing the complete picture from above? Those questions would lead scientists toward discoveries that few expected and interpretations that remain fiercely debated even today. In the next part, we will examine the most surprising patterns identified by artificial intelligence, explore why some researchers believe they completely transform our understanding of the Nazca lines, and reveal the remarkable evidence that continues to divide experts around the world. If the relationships identified by artificial intelligence were simply random coincidences, researchers expected them to disappear as more data became available. Instead, the exact opposite happened. Every new aerial survey, every improved satellite image, and every additional digital elevation model seemed to strengthen many of the same geometric connections. Patterns that first appeared uncertain gradually became more consistent. One of the most intriguing discoveries involved the orientation of multiple geoglyph groups spread across different sections of the Nazca Desert. Rather than existing as isolated works of art, many appeared to share common directional alignments that extended far beyond individual figures. From ground level, these relationships were impossible to recognize. But viewed together from high above, they created corridors of remarkable precision stretching across the landscape. Artificial intelligence highlighted these alignments repeatedly because they occurred too often to ignore. Archaeologists immediately began checking each prediction using conventional surveying techniques, expecting many of them to fail under closer inspection. Surprisingly, a significant number survived detailed examination. This did not prove that the Nazca people intended to create one enormous hidden image, but it demonstrated that the placement of many geoglyphs was probably far more deliberate than previously believed. As researchers expanded their investigation, another fascinating observation emerged. Certain straight lines appeared to converge near locations that contained no famous geoglyphs at all. At first, these points seemed completely ordinary, but when archaeologists visited them, they discovered subtle traces of ancient human activity, including pathways, disturbed soil, small stone features, and evidence suggesting repeated visits over long periods of time. None of these discoveries were dramatic enough to rewrite history on their own, yet together they hinted that the empty spaces between the famous drawings might be just as important as the drawings themselves. For generations, tourists admired the giant hummingbird, the spider, the monkey, and the condor because those figures were visually striking. Artificial intelligence encouraged scientists to focus instead on the invisible relationships connecting them. That shift in perspective changed the entire investigation. Instead of asking what each figure represented individually, researchers began asking how every figure interacted with its neighbors across the entire desert. Some experts compared the process to examining individual letters without realizing they formed sentences. Others described it as looking at single stars without recognizing the constellation. Whether those comparisons prove accurate remains uncertain, but they illustrate how dramatically the research has evolved during recent years. Another remarkable contribution from artificial intelligence involved the discovery of previously unnoticed geoglyphs. Using advanced image enhancement, the software detected extremely faint surface disturbances almost impossible to distinguish through ordinary observation. Archaeological teams later confirmed dozens of these newly identified figures, many of which had gradually faded through erosion or centuries of natural weathering. Some depicted birds and animals unlike any previously catalogued. Others consisted entirely of abstract geometric forms whose purpose remains unknown. What fascinated researchers most was not simply the discovery of additional figures, but where they appeared. Many occupied locations predicted by broader spatial models, generated before archaeologists even entered the field. Although artificial intelligence was not discovering hidden civilizations or decoding ancient messages, it was consistently directing researchers toward meaningful locations. That practical success dramatically increased confidence in using machine learning as an archaeological tool. Still, many scientists urged caution. Human beings naturally search for meaning, and computers can sometimes amplify that tendency by identifying mathematical relationships that hold little cultural significance. A perfectly straight alignment does not automatically imply intentional design. Random events occasionally produce impressive patterns, especially across enormous landscapes. Because of this, every proposed discovery required independent verification through excavation, dating techniques, geological analysis, and comparison with established archaeological evidence. Responsible researchers emphasized that artificial intelligence should assist human judgment rather than replace it. The technology could identify possibilities, but people still needed to determine which conclusions were actually supported by evidence. Meanwhile, entirely new theories began appearing within academic discussions. Some suggested that the Nazca lines functioned as ceremonial processional routes, connecting sacred places throughout the desert. Others proposed that the figures marked important seasonal activities linked to rainfall, agriculture, and underground water sources. Another hypothesis argued that the enormous network reflected social cooperation among different communities. Artificial intelligence did not prove any one explanation correct, but it supplied valuable new information capable of testing each idea more objectively than ever before. Perhaps the most exciting realization was that the mystery had not become smaller after decades of technological progress. It had become larger. Every improvement revealed additional complexity, hidden beneath what once seemed relatively straightforward. The Nazca people were clearly capable of organizing labor, planning enormous projects, and maintaining extraordinary precision over vast distances. How they coordinated such work without modern surveying equipment continues to impress engineers today. Even creating one perfectly proportioned geoglyph would have required careful planning. But constructing hundreds across such a massive region suggests an impressive understanding of landscape, measurement, and long-term organization. Artificial intelligence has helped scientists appreciate that achievement more fully. Yet despite all these advances, perhaps the greatest lesson concerns the limits of certainty. Popular headlines often suggest that technology has solved ancient mysteries overnight, but real archaeology rarely works that way. Every discovery opens additional questions. Every confirmed pattern invites deeper investigation. Every new theory must survive careful testing before entering accepted history. That slow process may seem less dramatic, but is precisely what makes genuine scientific progress so valuable. Instead of replacing evidence with speculation, researchers gradually build stronger explanations, one verified observation at a time. The Nazca lines continue reminding humanity that ancient civilizations were often far more sophisticated than modern people assume. Their creators left behind an enormous landscape that still challenges some of the brightest minds in the world. Artificial intelligence has not uncovered proof of forgotten visitors, supernatural technology, or impossible engineering. What it has revealed is something arguably even more fascinating. Our ancestors may have organized knowledge, space, and symbolism on scales we are only beginning to understand. Every new survey demonstrates that history still contains countless unanswered questions waiting beneath familiar ground. The greatest discoveries are not always hidden underground inside sealed chambers or buried beneath collapsed temples. Sometimes they have been visible the entire time, patiently waiting for someone to recognize the pattern connecting them. As satellites continue collecting higher resolution imagery, as drones map previously inaccessible terrain, and as artificial intelligence becomes increasingly capable of recognizing subtle relationships across enormous datasets, the Nazca Desert will almost certainly continue revealing new surprises. Future generations may look back on this period as the moment archaeology entered an entirely new era, one where ancient mysteries are explored not only with shovels and excavation tools, but also with algorithms. Whether the ultimate explanation proves ceremonial, astronomical, environmental, social, or something entirely unexpected, one truth already seems undeniable. The Nazca Lions have not finished telling their story, and thanks to the remarkable partnership between human curiosity and modern technology, we may be closer than ever before to understanding one of history's greatest masterpieces without losing the wonder that made it extraordinary in the first place.